In section 1.5, we're going to turn our attention to angles. We've mentioned them a lot, but we haven't really gone into detail about them. So first of all, we want to know the definition. How do you form it? What is it? So angles are formed by two rays that have the same endpoint. The rays are called sides of the angle. The common endpoint that they share is the vertex of the angle. And there are three ways to name an angle. So before we get to the three ways, let's talk about each one of these. An angle is formed by two rays that have the same endpoint. Notice here we have ray NM and we have ray NO. Okay, so M would be like a point on this ray and O is a point on that ray. And so these are two rays that share the same endpoint. This is the endpoint we're talking about. And if you go to here, it says that that common endpoint is called the vertex of the angle. Okay, these two rays, these make up the sides. So this is one side of the angle, and this is the other side of the angle. These are the sides. And so the angle specifically is this measure right here. How open are those rays? How closed are those rays? And so again, we get to the last thing here, which says that there are three ways to name an angle. You can either name it by its vertex. Okay, so here the vertex is N, so I can call it angle N. You can name it using 3 points. Okay, now if I name it using 3 points, the vertex always has to be the middle point. So I can name it MNO, or I can name it ONM, okay? But the vertex always has to be in the center, okay? Or if the angle is labeled with a number, you can name it that way as well. Okay, so it'd be like angle 1, and those numbers would be kind of inside. Angle 1 or angle 2 or angle 3. So now we're getting to naming the angles again. We're going to get into a little bit more detail, okay? Remember we said we could name an angle using its vertex. That's great as long as it's just one angle that has that vertex. But if I just say angle B, we're not really sure what angle I'm talking about here, because this angle has B as a vertex. Let's call this angle 1. And angle 2 here also has B as a vertex. So when the same vertex, or when the same point is a vertex for two angles or is shared, you have to name it using the 3 points. You can't name it using the vertex anymore, okay? So in this problem, the blue angle that I identified in here is angle ABD or angle DBA, and then the green angle is angle DBC or angle CBD. Again, the vertex, always the middle term, the middle letter, okay? Notice there's no commas, there's nothing. It's just the 3 letters side by side. Now, once you create your angle, the region that contains all the points between the sides of the angle is the interior of the angle. So remember that these angles, even though they stop here, technically this side or this ray, right, it's a terrible drawing, goes on to infinity, as does this one. It has this endpoint, but then it goes in this direction forever. So the interior doesn't really just stop here. The interior extends forever, okay? And again, the space that is inside of the sides, all of this that I'm highlighting right now, all of this would be considered the interior of the angle. The region that is outside of the angle, this area out here, all of this on the outsides, all the blue is the exterior of the angle, okay? So we want to make sure we can differentiate. The protractor postulate. Well, the protractor postulate basically says that when you create an angle and you match it up to a protractor, kind of like you do with the ruler postulate, right? Basically what we're saying is, hey, we're going to take this ray here. We're going to start with this original ray. We're going to have another ray. We're going to have point A over here, and we're going to create this ray through that. And by doing so, okay, we created an angle measure here. This has some kind of angle measure. It's open to a certain point, right? And what it's saying, the ruler postulate is saying that those points can be matched to degrees on a protractor, degrees between 0 and 180. Okay, so where do we get the 180 from and all that, right? Well, we have to take the starting side of an angle. And if we do the starting side this way to the right, okay, if the terminal side, which is this one, the last side, right, if that was right here, then it would be a 0 degree angle. We use these inside numbers here to tell us what the measures are. So let's say I have an angle that goes right here. Well, it goes through 40 degrees. So I know this is 40 degrees. And I read it this way. So as I open my thing, my ray, it goes all the way to 180. At 180, what I would be graphing is a straight line. Okay, and we're gonna cover that in a little bit. But if I go all the way over and end this way, this is 180 degrees. So what about the numbers on the other side, right? Well, if my first side started this way, through 0, obviously, it started this way, and I was to open my angle this way, like here, okay, then my angle goes in that direction. So I start at 0, which is the top numbers, and I read all the way until I get to here, which is 100. So if I'm going in this direction, I look at the bottom numbers. If I'm going in this direction, I look at the top numbers to get my degree measure, okay? And just like the ruler postulate, I'm able to find the difference or the degree of something by using subtraction. So for example, if I want to know what this degree is here, I'm going to take the absolute value. So I'm going to say AOB, angle AOB, is equal to, I know that this is 140 degrees, and it starts at 0. So it's going to be the absolute value of 140 minus 0, or just 140 degrees, okay? Now, it's really easy when it starts at 0, but this formula will help you if the angle starts, let's say, inside. Watch, let me give you a blue angle that I'm trying to say, like, or red here. Let's say I have a starting side here, and let's say I have an ending side here, okay? And I want to know what this angle measure is, right? Well, I have to look at the starting side and the ending, or the starting angle here. This is at 40, and this one's at 80. So the degree here in the middle is 80 minus 40, and it's the absolute value of that. So it's the absolute value of 40, or 40 degrees. And so I can do just like I did with a ruler. I can subtract. Now you say, well, hey, how did you know to use these inside ones? This one's a little weird because it doesn't start like over here, let's say. Well, I would have gotten the same degree if I had used the outer ones. Notice that the outer ones were 100 and 140. So if I do 100 minus 140 and take the absolute value of that, I'm still going to get positive 40. Okay, so even though that was negative 40, I'm still going to get positive 40 afterwards. So it doesn't matter as long as I use the two bottom numbers or I use the two top numbers. So what you saw in that other one that talked about the protractor postulate, again, here we're just talking about what a protractor is. It's a tool that we use in geometry, and it measures angle measures. Angles are measured in degrees. This is the unit of measure for angles, and it's represented by an open circle like that in the corner. So line segments are different. We measure line segments in unit like inches and feet and centimeters. angle measures are measured in degrees. So as soon as you see these degree symbols, you know you're not talking about the length of sides. You're talking about the degree measures of the angles. We classify those angles based on either the terms acute, which is angles between 0 and 90 degrees. So for example, again, if you have your starting side there, 90 degrees is a right angle, so this is 90 degrees. So any angle that ends in here, like maybe here to here or here to there, any of these angles, these are all acute angles because they are less than 90 degrees. The other big angle is what we call a straight angle, and a straight angle equals 180 degrees. Basically, what a straight angle is you start at your whatever side here, you start this side here, this ray, right? And you kind of open, and your ray ends on the other side. Basically, it forms a straight line, and that's equal to 180 degrees. And so, again, anything then between 90 and 180, well, that's your obtuse. So anything that falls like in here, let's say, we know whatever, this may be 110 degrees or 120 degrees or something like that. So again, you want to kind of recognize the different ones. So you want to envision in your head what an acute angle looks like. You know, it might look something like that. A right angle is going to look like that. It's always going to have kind of like this little square to kind of notify you that it's a right angle. An obtuse angle is going to be, you know, something that looks like this. Okay, it's going to be more than 90 degrees. And a straight angle is going to go this way. And so it's the full 180. Okay. So now we're going to look here at these different angles on this protractor, and using the protractor postulate, we're going to try to determine what the angles are. Okay, so let's start with angle GHK. That means the angle starts at this point, goes 2H as our vertex, and goes 2K. And so I recognize that this red angle is what I'm talking about. These two rays. The ray that contains M, the ray that contains L, and the ray that contains J. These are not important for this problem. So when I'm trying to find the measure here, I know it's the absolute value of these differences. If I start over here at 0, I'm going to go up and over until I get to this point here, which is at 125 degrees. Okay, it's between 120 and 130, right there in the middle. So this angle is 125 degrees. Because it starts at 0, it's easy. If I wanted to do the math, it would be 125 minus 0, and that's 125 degrees, okay? The absolute value, which is 125. So that's how I do the first one. I'm going to erase this, and now I'm going to look for the second one. I'm going to look for B. And B is angle JHL. So I'm going to start at J, I'm going to go to H, and I'm going to go to L, or through L. And so I know that these are the two rays that we're talking about. And I recognize that they go through 90 degrees, right? Obviously, since I'm starting on the right side, the 90 degrees that matters to me in this one is the bottom one. However, they're all the same. So again, I could do the absolute value of 90 minus 0, which is 90 degrees. But again, I don't need to do that since it started at 0. I know I'm just going from 0 to 90. That's 90 degrees. And I could identify it with this little square as well. Okay? So again, we're going to erase that one. And now we're going to go to the third angle. The third angle here we're going to look at is going to be LHK. And so LHK, I just kind of see it as starting at L, going to H, and then to K. And again, since I know these are rays, it goes out this way and out that way. But this is the angle in question. So I can identify these angles, again, by the absolute value of the difference of their points. If I use the bottom numbers, it's 90 and 55. This goes through 55. So it's going to be 90 minus 55, which is 35. and the absolute value is 35. So the measure of this angle is 35 degrees. If I use the upper numbers, they're going to work as well. I've got 90 up top, and this would be 125. So I would come here and I would do 90 minus 125. I know that that's negative 35, and the absolute value is 35. So again, it's 35 degrees either way. Next thing we're going to talk about, now that we know how to identify angle measures, we know how to use the protractor postulate, we know how to classify angles as being acute, right, obtuse, or straight. Now we're going to talk about congruent angles. Remember, congruent means same size and shape, okay? So here what we're saying is congruent angles are angles that happen to have equal measure, okay? So if angle A is congruent to angle D, or if the measure, so this is where we have to learn the words, right? Notice this has an M here, another M, and it says equals. What this is saying is the measure of angle A. And when we talk about the measure of angle A, we're saying the numeric value of angle A is equal to the numeric value, okay, of D. Okay, of angle D. So we use the equal sign and we use the letters M. We're talking about the specific measure of the degree. This is where we're saying like 35 degrees equals 35 degrees. Okay, so we're talking about the number. We did this when we did line segments. Remember we said segment, AB is equal to segment CD or something like that, and we told you that when you see the equal sign, we mean that the numbers are the same, the numeric value of the length. This is the numeric value of the angle. When you see a statement like this with the congruent mark, this is just telling you that these two angles, angle A and angle D, which are two separate angles, are congruent. They have the same size. We're not talking about what size they have. We just know that they're the same. So when we get to postulate 4, we get to our angle addition postulate. And again, this just like segment addition postulate, we called it SAP. This is angle addition postulate, and you can use AAP for short. And the angle addition postulate is very similar to the segment addition postulate. What this tells us is if point B is in the interior of angle AOC. So what we have is we start out with angle AOC here, okay? Point B is some point in here. And if we go through that point, if we draw a line through that point, what happens is we take this large angle AOC, and now we're breaking it into two other angles, like AOB will be now one angle, and BOC is a second. So we realize that we took one large angle and we sort of split it into two smaller angles. And so what happens is we're saying that AOB plus BOC, this blue angle plus this green angle, are equal when you add them up to the original large angle that they're inside of, okay? So again, it's a part plus a part equals the whole, if that makes sense, okay? So what would happen if the original angle, instead of AOC here being like an acute angle, what if the original angle that we're talking about happens to be a straight angle, like JKL? Notice this is like here, here, and here. This is 180 degrees, right? We know that. So if I take a point on M here, if I draw this ray and I split JKL, that straight angle, into two angles, notice now I have a larger blue angle and a little blue angle, right? But basically I took that full 180 degrees and I split it into two parts. So I know that this angle here, JKM plus MKL, have to add up to 180 degrees, which I know the whole thing equals. Okay, again, the two parts have to equal the whole. So that's what this angle addition postulate is telling you. An angle bisector, remember that a segment bisector splits a segment into two halves? Well, an angle bisector does the same. A bisector of an angle is a ray that divides an angle into two congruent adjacent angles, which is an interesting word. So what this is telling me is I have this original angle ABC here, right? I have this ray here, BD, which I'm told is a bisector. So as soon as I know that this is an angle bisector, I know that the two pieces that it created are congruent, which means their measures are equal. So if BD bisects ABC, that means that angle ABD is going to be congruent to angle DBC, okay? It also means that the measure of angle ABD, right, is going to be equal to the measure of angle DBC as well, okay? So last few things we have to cover, we've kind of covered this in another class. We talked about this as well, these congruent marks, okay? So when we deal with side lengths or segments, we know that the tick marks mean that the sides are congruent. If I use one tick mark for AE, I'll use one tick mark for ED if it's the same, okay? And the same thing goes for angles. If these two angles here are equal, I'll use one tick mark and one tick mark, okay? And the last thing we talk about is that a right angle always is represented, or we identify it one way by doing that little square there to identify that it's a right angle. So now we've got a whole bunch of questions to practice. Now we're going to put it all into practice. So we have to take our time and be very careful to try to figure out exactly what's being referred to. So we're going to go slow on this. We've got angle DEB. So let's find that angle. I'm going to start at point D. I'm going to go to E, and then I'm going to find B, and it's over here. And so I know that if I follow DEB, the angle that I'm referring to is this angle here. And so another name for that angle is angle 4. Now, I can't call that angle angle E because angle E refers to two different angles, angle 3 and 4. And so since it's not clear, I can't just use the vertex. So I have to use the number on this one, okay? Another way that I could name it, I could switch the letters. I could do, instead of angle DEB, I could do angle BED, as long as I keep the E in the middle, the vertex in the middle. So I could have named it like that, but I would like a different thing. Instead of just switching the order, try to use a number or the vertices. Then I'm going to erase that, and I'm going to go to the next problem. So the next one I'm going to do is angle CBE. And so I'm going to go, again, I'm going to start at C, I'm going to go over to B, and I'm going to go up to E. And so again, I recognize that the angle they're referring to is this one. And while that angle looks like a right angle, I'm not going to make it a right angle unless I'm told it is. I can't just eye it and assume. This could be 89 degrees or 91 degrees or whatever. So never assume it's a right angle. It has to tell you it's a right angle, okay? So this angle here, the other name for it would be angle 8, okay? So again, we keep going. Go to the next one. BEA. So angle BEA. So again, I start at B, I go to E, and I go to A. And so I realize that the angle formed by those two sides is this one. And that would be angle 3. Next, I'm going to go to angle DAB. So again, start at D, travel to A, and then go to B. So D, A, and B. And I recognize that that's the angle that we're talking about, and that's angle 1. Okay? Again, I still can't name it angle A because angle A refers to two different angles, and I can't do that. Okay, so we keep going. We go to number 5, another name for angle 7. So angle 7 is made up of this side here, right? Oh, geez. I don't know why I did that so wrong, right? So I've got this side here and this side here, right? So the easiest name to give it is just angle C. Notice that C, the vertex, only refers to that one angle. So I don't have to worry about using 3 letters. However, if I wanted to use 3 letters, I could also call angle 7, I could say ACE. I could call it BCE. That's another one, right? And I could switch the A and the E or the B and the E and just keep the C in the middle. So there's a few names I can give it. Obviously, just you only need one, okay? Okay, so we go to angle 9 here. So we're talking about this angle here. And again, I'd love to name it angle B. It's easier. However, B refers to 2 angles here, so I can't do that. So I know that angle 9 is made up of these 2 rays right there, or not really rays in this case. They're made up of 2 segments. But it's going to be then, I can call it angle ABE, or I can call it angle EBA. I can go in that order, okay? So we keep going. We've got, here it says the measure of angle 1 plus the measure of angle 2 equals the measure of which angle? So let's think about that. The measure of angle 1 is this one, right? The measure of angle 2 is this one. So those 2 together combined are going to equal this angle here, right? So this is the angle I have to name. So it's the measure of angle A. That's the easiest way to name it. So the 2 parts, 1 and 2, are going to equal the whole, which is angle A. When I go to the next question like this, it says angle 3 and angle 4. Angle 3, the measure of angle 3 plus the measure of angle 4 equals the measure of which angle? Again, here's angle 3, here's angle 4. And so what does it equal together? Well, it equals this big angle here, which is basically angle E. Okay. And then our last question here says the measure of angle 5 here plus the measure of angle 6 here equals the measure of what? So again, what does that equal? Well, it equals this straight line here, okay, which is the whole thing. So that's going to be angle, the measure of angle EDC, which we know in this case is 180 degrees. We actually know the measure of that because that's a straight line, okay? But we just want you to write the letters. So EDC or CDE. And then our last slide. Given that, and we have to read it, and again, this is how you're going to see these problems. Given that the measure of LKN is 145 degrees, so first of all, LKN is this red angle here, from here to here. So LKN is the whole thing, okay? So the whole is 145. Find the measure of LKM and MKN. So LKM is this blue angle, and MKN is this green angle here. So obviously we know the parts add up to the whole, right? So we know, let's just write this out here. We know that the measure of the whole thing, LKN, is going to equal the sum of the measure of the blue angle, LKM, plus the measure of the green angle, which is MKN. Okay, so now that I have the setup, let's actually write it out. The whole angle is 145 degrees. The parts are LKM, the blue, is equal to 2x plus 10 degrees. And the other one, the green angle here, MKN, is equal to 4x minus 3 degrees. So notice that basically I just have an expression now. The two parts added together equal the whole angle. They told me the whole angle was 145 degrees, so I should just be able to do the math now. 145 degrees equals, combine my like terms, 6x plus 7. These like terms will add up to 7. And then I can subtract 7 from both sides. I'm going to get 138 equals 6x. And I'm going to divide both sides by 6. And I'm going to get that x equals 23. Now again, x equals 23 is great, but nobody asked me for x. They want to know what each measure is. They want to know what is the measure of angle LKM. Well, again, LKM is 2x plus 10. If x is 23, then it's going to be 46 plus 10, or 56 degrees. So then, if that's LKM, then MKN is what? Well, again, it's going to be the formula that it was given, or the expression is 4x minus 3. So if x is 23, I'm going to get 12, carry the 192 minus 3, and I'm going to get 89 degrees. So this angle is 56 degrees. This angle is 89 degrees. Now, how do I know if I'm right? Well, let's add it up, because I know that 56 plus 89 has to equal 145 degrees, because that's what I was told. The parts have to equal the whole, and it does. So these are the answers to this problem, 56 and 89.